Okay. I talked in another video about the zona glomerulosa and aldosterone. Now let's go to that middle layer, zona fasciculata, and they make glucocorticoids. So when you see the word corticoid, you often think steroids. Glucocorticoids are steroids. Steroids, as you know, steroids, as you've heard of them before. And I just gave you some examples: cortisol, hydrocortisone, prednisone, a med pack, whatever. Those are all examples of steroids. They're something that your body makes. And so when we talked about the mineralocorticoids, aldosterone, we didn't make any mention of the pituitary gland. The brain didn't trigger that process. That process was triggered by being dehydrated. This is triggered, this middle one is triggered by the pituitary gland. The pituitary gland sends ACTH, adrenocorticotropic hormone, down to the zona fasciculata, that middle layer of the cortex. That's going to trigger the release of steroids. So let's talk about what steroids do. This is what they do, right? In high doses, they're immunosuppressant. That doesn't mean your body is going to do that. But, you could give steroids, like prednisone is a common steroid to get after certain operations or in certain cases with autoimmune diseases, things like that, because it acts as it suppresses the immune system, right, in high doses, right? But let's talk about what it naturally does. Helps you deal with stress, mental stress, emotional stress, physical stress, right? Stress in all understandings we have of stress. Steroids are anti-inflammatory. That's another reason that it's given. So if you have tendinitis, it could be a steroid shot is going to help you pretty quickly, right? So it's anti-inflammatory. Let's talk about these bottom three things. These bottom three things are common to a few different hormones. They're common to steroids. They're common to growth hormone. They're common to thyroid hormones, which regulate your metabolism. So we've got two different things going on. Let's take the bottom one, increased amino acid use. That's all about proteins, right? Whenever you want to heal a wound, whenever you want to heal something, fix something that's gone messed up with your body, you need proteins. Whenever you want to grow, you need proteins. Whenever you want to maintain what you have, you need proteins. Proteins, right? So it's all about proteins. So here, steroids increase amino acid use. Why? Because you have to make a repair. You sprained your ankle, you have to repair tissue. Whatever it is, you have to repair tissue. And to repair tissue, you need two things. One, proteins, because that's the ingredient we use. Two, you need an energy source. So you need the protein and you need energy to make the proteins work. That's these other two. So two sources of energy are sugars and fats. Sugar is more of like a short-term type of energy and fat's more of like a long-term type of energy. But anyway, we need them both. So we're going to take fats and sugars and we're going to make ATP with them. That ATP is the energy source to manipulate amino acids to make more proteins. So you find the same thing with growth hormone, just for a different reason. With growth hormone, you're increasing amino acid use. Why? Because you're growing, but you need energy to do that too. So you're going to increase the breakdown of fats that you have in your body. That's this one down here, lipolysis or lipolysis, right? Breaking up fat. Lysis means to break up. Lipo means fat. You're breaking up fat, your body's fat stores. And then you're increasing the availability of glucose usually by breaking down a molecule called glycogen. Right. So in the case of human growth hormone, that's because you're growing. So that's kind of taken to the extreme. right? In the case of thyroid hormones, that's just everyday metabolism, everyday maintenance, right? That process is not happening so much, and it's not to repair tissue. It's just to grow hair and do all the things that you do every day. With steroids, your body's often trying to fix something. So we need the amino acids, and then we need the two energy sources. We need to increase the amount of blood sugar, and we need to increase the amount of lipids available. Both of those are going to be turned into ATP, and the ATP is going to make the create proteins. So these three at the bottom, they kind of go together. But then there's these other three on top. The first one and the third one are kind of supplemented. So you'll see that in healthcare settings. This middle one is a natural response of steroids. I think we have time to do one more. Let me break away from the cortex. Let me talk about the medulla, because it'll be pretty quick. It's right here. The medulla, the creamy filling of the Twinkie that is the adrenal gland, produces what are called a class of chemicals called catecholamines, but I'm mostly interested in these two, epinephrine and norepinephrine, previously referred to as adrenaline and noradrenaline. So this is what they do. Again, you're seeing some things that are similar. Look at these two bottom ones. Increase, or that's what I mean, lipolysis, breaking up fat. And then look at the bottom one, increase blood glucose. Same thing. Why does your body want to do these two bottom ones? Because we need to increase the amount of ATP that we have. Because it's adrenaline. It's your fight or flight response. It's a sympathetic response, right? Sympathetic is fight or flight, right? So there's a bear chasing you. What do you want to do? Run, or try to fight it out with the bear. So for most of us, we're going to run. So what do I need to run? Well, I need energy. I need to get some energy down to my leg muscles, like now, right? And a lot. So how do I do it? I got to break up fat. I got to dump sugar into the blood. I got to make that energy available. And I have to get it down to my legs a lot quicker than me just sitting here talking to you. So that's where you see increased heart rate. Yeah, because you want to get the blood flowing, right? So you want to increase heart rate. You want to get blood flowing. That's epinephrine. I've kind of put epinephrine and norepinephrine together. There are some slight differences we'll talk about in another chapter, but that's essentially what it does. You want to increase blood flow because you want to increase the amount of energy you're getting through your body. Okay, so definitely know this slide. Definitely know that slide. It'll be a question eventually. And yeah, I think we're good. So I will stop here.